purpose of this mini lecture is we are going to be talking about calculating chemical quantities, and a lot of the chemical quantities we calculate involve the mole, and we're going to talk about some of those quantities and how they relate to the mole. And we're going to start out with just kind of putting together a schematic or a diagram saying how these various quantities relate to the mole and how do you navigate through there, and we'll show an example problem towards the end of this video. The mole in this section is kind of our central character. It really relates to a lot of different chemical quantities. And first and foremost, one that we know we can relate the concept of the mole to is the number of particles that we have present. And just like we would say that if we have a 12 of something, we have a dozen. We have a certain number in chemistry we say are moles, and it doesn't matter what particles we're talking about, you can group them into moles, just like it doesn't matter what particles we have, we can group them into dozens. So it doesn't matter if we are talking about if we're talking about shoes or marbles or donuts or eggs or atoms or molecules, we can group them into dozens. We can also group them into moles. And of course, in chemistry, we really are mostly interested in grouping the particles of atoms, of molecules, and of formula units. And a formula unit is just the smallest piece of an ionic compound you can have. So if you just look at the formula for an ionic compound, you can kind of count up the atoms that are there, but that would make a formula unit. So if we had, say, sodium chloride, NaCl, well, one sodium and one chloride, that would make up its formula unit. And we say how it relates to the mole is we would say 1 mole would contain 6.02 times 10 to the 23rd particles. Another quantity that we can relate to the moles is this one's a little bit more practical. In the lab, we can't count individual particles. We can't even see the atoms, but we can measure the mass of things, and we get a balance in the lab, and we do this all the time. And the quantity and the way that we relate this to moles is that we can calculate the number of grams there are in 1 mole of something. So we say 1 mole is equal to some number of grams, and we do that by calculating the molar mass. The third quantity that we relate to moles is if we're talking about gases at STP, and STP just means standard temperature and pressure. It's not really important right now that we know what those conditions are. What's important that is if you have a gas and it says it's at standard temperature and pressure, 1 mole of that gas will have a volume of 22.4 liters, and it doesn't matter what gas it is. For gases, what's really important is that how much empty space you have between the particles. So if you have 1 mole of particles, that those particles, we say we have 1 mole, and it takes up a volume of 22.4 liters. Now, at this point, we should say the star of our show here are the moles. So all of these conversion factors that we're using are all on the basis of 1 mole. So later on, when we're doing our dimensional analysis, when we plug in our numbers for the mole, it will always be 1 mole, which means you need to memorize some of these other numbers. So you should memorize 6.02 times 10 to the 23rd particles in a mole and 22.4 liters in the mole. And you should know how to calculate the molar mass. And if you don't know how to do that, you can go look for my video, Calculating the Molar Mass. It's all laid out there. So let's look at a sample problem here. We have what is the volume of 89.3 grams of oxygen gas at STP? Well, we're going to refer to our roadmap here, our little schematic, and try to figure out how we're going to navigate through this problem. So like anything in life, when you look at a problem, you want to look at where are you, where do you want to go, and how are you going to get there. And so first of all, we look at this problem says that we have some information about the grams of the oxygen gas. Well, grams is a measurement of mass. So where we're starting here is at this corner down here in the lower left corner of the mass. So we say, where do we want to go? Well, the question's asking for the volume of the gas at STP, so we want to get up here to the volume of a gas at STP. Now, if you notice, there is no direct connection between the mass of a substance and a mass of a gas and its volume at STP. In this case, our road takes us through the moles. So we look and say we're going to have to do two steps here. We're going to have to convert first from our grams into units of moles, and then we're going to convert from moles into our volume. So one thing to note at this point, what part of our highway here, our road map, what road are we not going to go down? Well, at this point, we are not going to worry about those particles down here. It's just not something we're interested in. Now, sometimes this throws my students off a little bit because they see that we're dealing with moles and they suddenly think, well, we know that a mole contains 6.02 times 10 to the 23rd particles, and they think they have to put that number in there. But for this problem, we're not, because the question isn't giving us any information about the individual molecules of oxygen, nor is it asking for it. So if it's not talking about the number of individual particles, we don't have to worry about the 6.02 times 10 to the 23rd. So at this point, we'll just kind of shrink that down so we have some room to do our dimensional analysis. We can put our starting and ending points here. We're starting with our 89.3 grams of O2. And we know we want an answer that's talking about the volume, where our answer is going to be in liters. We know we've got two steps, so I'm going to insert the space here for two dimensional analysis conversion factors. And so our first step is going to be to get from the mass in grams to moles. And we know we've got to get the grams to cancel. So right now the grams of O2 are above the line, so we're going to put our grams of O2 below the line. And we're trying to convert from grams to moles, so the mole term will go on top. Our second step is to convert from moles into the liters of the gas. And so now to get our moles to cancel, we'll put the moles on the bottom, we'll put our liters on top. And we always say that with these mole highway calculations, the mole is number one. The number one always goes with our mole term, so we'll put in our ones there. Now, for oxygen gas, it's diatomic, it's O2. So when we calculate the molar mass, we've got to take the atomic mass of oxygen, which is 16, and multiply it by 2, and we find that it's 32 grams of oxygen per mole of oxygen. And the second conversion factor here is, since this gas is at STP, we know we can put 22.4 liters in for this portion of the calculation. We double check. Our units cancel. Our grams of O2 appear above and below the line. They cancel. The moles appear above and below the line. They cancel. We're left with the units of liters. So we say that's exactly the unit we're looking for. And we can calculate that this is going to have a volume of 62.5 liters. And so for more examples, coming soon and should be on there, the mole highway practice problems. You can check on a video. We'll have more of these mole highway calculations.